Okay, so this video is Prisms and Cylinders. You got to work in class and do some fun stuff with just basic solid vocabulary. And from here on, we're going to work with the measurements of those things. And so we'll start with prisms and cylinders, and then next week we'll move into pyramids and cones and spheres. Okay? And so prisms and cylinders are pretty basic, and none of these formulas should be new. You should have dealt with them in 8th grade. But I still need to go over and make sure we're all on the same page, because we know we're going to take it up just a notch here. Okay? And so one of the first things that I need for you to understand is why I group them together. There's a reason why I put prisms and cylinders together. They have some things in common. Okay? And so I know it's not going to be easy for you to fit this in your space, but you can write it however you can fit it. Prisms and cylinders both have two bases that are parallel and congruent. Okay? So they're going to have two flat surfaces. The only difference is with the cylinder, that base is a circle, and with the prism, that face will be a polygon. Okay, but they both have parallel and congruent bases. They also both have a rectangular lateral surface, and let me show you what I mean by that. We're going to actually color those parts here on our picture. Okay, and so let me get a big color there, big old fat marker, and I'm going to color our bases. So our bases are going to be blue, B for blue, B for base. And I want you to do the same. So if you need to pause and go grab a highlighter or a marker or steal your little sister's crayons, whatever, it's fine with me. When I unfold it to get this net here, you see here's that same base. Okay? And then we've got for our cylinder, our base, our flat surface is the circle. So then here's those two bases. When I unroll it, you saw the nets that we worked with in class in your stations. And that a cylinder unrolls like this. Now I know I can move that circle up and down that however I want, but I got to have one circle on one side and one circle on the other. And they'll never touch because they're parallel. And so then the other thing they have in common are those rectangular lateral face surface. So remember, lateral is everything that is not the base. So everything else in my picture is lateral. And I see it here. Okay. And then here's the big dog right here. Here's what I want you to notice. When it's unfolded, look what happens. Dun, 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 dun. It's actually one giant rectangle. Okay? So on a cylinder, we know these aren't actual different faces, but when I unroll that, we find, again, a rectangle. So that's how those two are similar, and because of those similarities, they also will have the same formulas for volume and surface area. Okay, so let me color this lateral area here. All right, so we're going to start with surface area, and surface area is quite simply the area of the surfaces of a 3D figure. Duh, right? We can deal with two different types of surface area. It could be referred to as total or lateral, and so total means everything, lateral means not the bases, so just the sides. Some key places that we use it is with wrapping paper. If I'm wrapping a present, I need to know the surface area of that present to make sure I have enough paper. Painting, if I'm painting the walls of my room, I need that lateral surface all the way around the room, because I'm probably not going to paint the ceiling and the floor. Icing a cake. Now, we usually don't ice the bottom of the cake, but we ice the top and the lateral surface. So we'd have one base, and then we'd have the lateral surface. But that's all considered surface area, because it's the area of that outside. Okay. Another key word that you might use is sometimes they'll say how many square inches or square feet, and that word square should clue me into the fact that it's got to be area, because area is what is squared. Okay. All right, let's move on down and let's check out what volume is. Volume measures the amount a figure can hold or the space it takes up. Okay, so they could say the volume of this truck is so many cubic, or truck bed is so many cubic inches. That does not mean that it has, you know, that much cubic inches of truck. It's saying that's what it can hold, so I can make sure I have enough space to put all my junk to get it out of there. Okay, or they could say this container of paint has in it, I don't know, 3 gallons. That's the volume of it. Okay, we usually deal with volume in cubic units. Okay, we deal with volume in cubic units, so whereas the key word for surface area might be inches squared or feet squared, with volume it would be cubic inches or cubic feet. And also another thing is liquid. Anytime I'm dealing with a liquid, with the exception of like painting on a wall, if I want to know how much water or how much Kool-Aid, that has to be volume. because liquid I can't measure in area. I can't pour it on the ground and measure how much there is, because it just doesn't work that way. Okay. Alright, so let's work with those formulas. We said they're the same. Let's see what they look like, and let's work with them. We're going to start first over here with our prism. Okay. And this is a triangular prism because it's named after its base, and the base is a triangle. And so we want to look at our formulas. Now I've written them in here, and the formula for surface area, if I want just the lateral, is big P times H. For total is big P times H plus 2B. So we've got to know what those things mean. Well, H is clearly the height, but what I want you to recognize with that height is it's not necessarily how tall it is off the ground, because notice this one's not sitting on its bases. Okay, it's the distance between the bases. So we're going to make a little note here, and we're going to say that height is between the bases. Read it, I'm going a little bit faster here. Between the bases. Okay, and so in this case, since my triangle is my base, then this 6 is what becomes my height. Okay, because that's between the two triangles. This is my H. Okay, now that one you probably knew right off the bat. Okay, but the P and the B, I want to make sure that you haven't forgotten what those are. Big P stands for perimeter of the base, and big B stands for area of the base. So those both refer to that triangle right there. So if I'm looking at this triangle, right now I can't find the perimeter, but notice the little right angle. Yep, those right triangles aren't going away. There'll be times where you have to do some Pythagorean theorem and things like that in there to figure out the big P or the big B. So in this case, that would have to be 5. I made it a nice, easy one, so it's a 3, 4, 5. So big P then would equal that perimeter of the base, which is 3 plus 4 plus 5, which is 12. So big P is 12. Okay. We already know our H is 6. And so the only thing left to find is big B. Big B is area of the base. Area of a triangle we know is 1/2 of the base times the height. Because I've got a right angle in there, we will call 3 and 4 the base and the height. So I need 3 times 4 divided by 2. Don't forget to divide by 2. A lot of us did that on that area test. Okay, so 3 times 4 is 12, divided by 2 is 6. So big B that we're going to deal with is also 6. Once I have those measurements, it just turns into me plugging them in. But I want you to see, I want to take a moment to make sure you understand where this formula comes from. So you remember up above where we unrolled that net, and we saw that that perimeter, that lateral surface always made a rectangle. Okay, if I look at that rectangle, notice that this part of the rectangle, the up and down part, the vertical part, is the height, and then the other part is what would wrap around my base. And so that's what makes that the perimeter of the base. Okay, and so that's where that comes from, perimeter of the base times the height. Okay, so in this case, it would simply be 12 times 6. So 12 times 6 is 72. Okay. Now when I go to total surface area, remember lateral was everything except for those bases. So it only makes sense for total to be my lateral plus my bases. Okay, and we have two bases. So my lateral was 72. That's the pH part. And my bases are each 6. So 2 times 6 is 12. Write it in so we can see later on where that came from. And so that comes up with a total surface area of 84. Now we want to make sure we include units where they're given to us. So this was meters, they're meters. Meters squared in both cases. Surface area is always squared. Volume's pretty simple. Once we've already done the work for surface area, that means we already have our B and our H, and so all you're doing for volume is multiplying the big B times the H, because you can think about it as my whole figure is basically that base stretched for however long that height is. So it's the area of that stretched over that height of 6. Okay, and so this would be 6 times 6. So in this case it would be 36. Volume is cubic, so this would be meters cubed. Okay. All right, let's move on over to our cylinder, and we said their formulas are exactly the same. In fact, on the formula chart, it just says prism or cylinder. Like, it doesn't even have a separate spot for it, okay? And so we need to figure out what that big P and big B and H are, okay? And so big P we call perimeter of the base. Well, if it's a cylinder, what is the base? The base is a circle, right? So the perimeter is the same thing as circumference, okay? So perimeter of that base is going to be 2 pi r. And we're going to leave everything in terms of pi here to make life nice and simple on us, okay? So if that diameter here is 12, then that means my radius is 6, okay? And so I can find my perimeter. 2 times 6 is 12. That means my perimeter is going to be 12 pi. Okay, and then we need our height, our h. It's still the distance between the bases. So between my circles, we have 10. So the height is 10. That's an easy one. And then our big B. Big B is area of the base, and my base is a circle. So that's going to be pi times my radius squared. So in this case, 6 squared is 36, so we wind up with 36 pi. And hopefully you're getting really comfortable with that terms of pi. Okay? Alright, so let's go ahead and plug them in where they go. Our lateral is perimeter times the height, so that would be 12 pi times 10, which is 120 pi. You are so welcome to write out the steps. It's just my handwriting. It's hard to write small in here for me, and so I prefer to at least give you the right answers if I can't write all the steps. Okay, for total, we've got 120 pi. Remember, that's the same as this. Okay, so it's 120 pi. It's the lateral plus our two bases. So 120 pi plus two of those bases. Each one is 36 pi. So that would make 72 pi together. And when we add those together, 120 plus 72, we should come up with 192 pi. 192 pi. Now, if you look on your formula chart, I believe it actually gives the formula in terms of pi, but it works out the exact same way. Okay. All right, volume. Volume is big B times H, still like it was. Okay, so my area of the base was 36 pi. 36 pi, and I want to multiply that by 10. And guys, I know some of us get confused when we throw that pi in there, but all you're doing is leaving pi alone and multiply the numbers. My height was 10, so this comes out to 360 pi. All right, now for some of you guys, I will not see you on Friday. I have to take a half day. So be ready and able to work with this. Basically, you can expect to do some practice with surface area and volume for prisms and cylinders. Now, no, they're not all going to be this simple. Some of those prisms might have a hexagon or a regular pentagon, heaven forbid, that you've got to work that Apothem formula. So they won't necessarily stay this simple, but the formulas stay the same. Okay? All right? See you when I see you.